Hello, hello. Welcome to the Comma AI office. As I promised, we'll be doing a live stream at 12. Yeah, we'll wait for a few people to get in here. I do want to apologize for the sunglasses. I don't think that they make me look cool. I hurt my eye, so that's why I'm wearing them, and that's why I wore them in the press. You hurt your eye right before press. What do? You wear stupid looking sunglasses, but try to make it work. Oh, someone's at the door. We have a chef now. We have I think it's the chef. Am I whispering? Can you hear me well? I'm in the office. There's other people here working. We can kind of maybe look around a little bit. So it's going to be a little more quiet than my usual periscopes, but hopefully you guys can hear me well. Sound pretty good. All right, I like that. So yeah, we're going to be reversing the Prius today using Kibana. I am pointing my phone camera at my monitors because I don't know how to live stream on Periscope, and I was talking to press for most of the morning, so I didn't have time to look into YouTube streaming. There's something else we're also going to be doing on this live stream, so let's switch over to the other camera here. So here is Kibana, and over here is the number of pandas we've sold. 336 pandas. Now, I wish that map was actually where the pandas went to, but that was kind of hard to do, so that's actually the map of the Schiffer users for the last 24 hours. But yeah, here we are pointed at Kibana. Can I zoom out? No, I can't. Hey, Peter Bench. I can't zoom out. So I have my phone on a mount. I'm using a mount like the same ones we use for Schiffer. Maybe I can... Yes, we have Comma Kibana up here. I need Viv back to hold the camera. Yo. This ain't bad. I think this will work. So everybody check it out if you haven't seen it. Here is a Comma AI panda. The production pandas will look even better than this. This is a Rev B panda. All pandas that are going to be sold will be Rev C pandas. Rev C pandas function as phone fast chargers, as they have 2 GM LANs, they can plug into your computer without an extra cable, and we got another panda sale. That's 337 pandas. Keep it coming, keep on buying pandas, and I will show you some of the stuff that you can do with a panda and this tool we've created called Kibana. So if you guys tuned into my other live stream, not my most recent one where I streamed OpenPilot going to Best Buy, I used the this stuff on the Toyota Prius. So let me just move here to when we're actually driving. So this is my driving video. This was actually captured with a Neo, but it looks exactly the same if you capture it with Schiffer. Probably even looks better because phones are better at knitting the camera than Neos are. Neos are knitted for machine learning. Phones are knitted to make good-looking pictures. So let's wait for this to load up here. There's a lot of load on our servers today. A lot of people are getting into Comma AI for the first time. So I've already found a few simple things. You can see this is like the wheel speed plot. Oh, no, it's not buggy. Okay, cool. It's just loading. Yeah, those lines on the graph are a little annoying. We'll have to check them out. Yeah, that's not perfectly synced up with where I'm clicking. It should be. Let me just refresh this page here and we'll see what we get. 338 pandas. So I'm also on Twitter. I'm looking at the news and I'm looking on Slack. I will also try to look at this Periscope screen. So what we're seeing here is the video from my Prius drive correlated with the messages that were actually on the Prius CAN bus at the same time. Okay, we can go to landscape mode. Let's see what we can do here. These phone mounts, this isn't really how phones are meant to be used, I don't think. No, this does this. I think the portrait was better. An update to do what? So we will probably release a firmware update maybe next week that starts to add some of the, so all of the software functionality like the Elm 327 emulation mode and the Windows support and the Linux driver support, that's all going to work on RevB as well. Support more cars. Well, if you want to support more cars, to support more cars with the Pandas, yeah. So yeah, I mean, some cars don't expose that much on the OBD port and will be constrained to getting sort of the same things that the typical dongles get because the manufacturers just didn't put the data there. Now, you can get around this by wiring the Panda directly into the CAN bus of your car. It's less hard to do than it sounds. And okay, here we are. So this is a plot of the wheel speed and the Prius. Now, let's see what we can find here. So I identified this signal as the brake. Let's see if that's true. So this is the brake amount. Now, on a Prius, you have two kinds of brake. You have the regen brake and you have the physical brake. Now, I don't like when I'm clicking here how it's jumping to the next thing. I thought this bug was fixed. Let's try refreshing again and seeing what we get. And we are up to 341 pandas. And one of the really cool things about this whole ecosystem is you're not constrained to use, like when you log the data, it literally logs all of the data from your car. It doesn't just log what we understand now. So when you log it, you can look in the future. If somebody figures out where a signal is on a car, you'll be able to get access to the information on all of your past routes as well. All right, now it looks fixed. It looks fixed until I scroll this. Also, yeah, I think we need to stand up a bit more. So the demo link has been posted in all of the articles, and literally we're getting, hundreds of hits per minute to this interface. So that's why everything's a little bit laggy and slow. Okay, so now you see what's happening when I click there? It's jumping. Clicks here, and then it jumps. Let's see if we can go on Slack here and get Andy over here to take a look and speculate at what might be happening. So this app is written in React. It's really easy to go in and push changes out. Seeing a Cabana bug on the live stream. Can we look? Let's see what we're getting on Twitter. Yeah, so these lines are here, which has something to do with, I think, the times not being synced correctly. Hey, welcome to the live stream. Everybody, do you want to welcome Andy? So Andy here is the one who wrote Cabana, and I'll show you the bug we're seeing. So when I click here, it jumps. See what I mean? Like I'm clicking here, and I thought we fixed this. I'm also still seeing the lines in the graph. It doesn't seem to happen on the first Prius segment. It seems to only happen when I scroll to the next Prius segment.
All right, well, we'll go ahead and take a look at that and make sure it's fixed for everyone today.
Cool. Maybe can we deploy a live internal version? So I can use the live internal version on the Periscope, and then once we do all these bug fixes, we'll push it out to everyone?
Okay.
Cool. So yeah, this is why we have teams of people working to make this stuff stable and great. Let's go over here and look at our panda numbers. So we've sold 344. Keep it coming. More pandas, more pandas, more pandas. So some of the things we want to look for in order to make the Prius supported by OpenPilot is how the Prius is actually controlling the brakes and the steering. So this brake packet here looks to be the actual brake that the car is doing, but it's not necessarily the command that you send to the car in order to trigger a braking event. So for that, what we have to do is we'll find in the video, so if you guys remember, everybody saw me do this drive, we can find where the ACC hit the brakes. It's probably this thing here, right? So you can see that I'm coming to a stop there. You see how it's out of sync right now? That's the bug we gotta fix. It should be much better in sync than what you're seeing right now. If we go over to the demo route, I can show you how in sync it is. So actually anybody can go to this URL, community.com/AI/Cabana?demo=1. So this is the demo route from the Acura. And you'll see on this one, when I plot the steering angle, and when I go in like to the powertrain data, and I plot the transmission speed, you'll see it sync up really well. So you see when I click on this here, we're going to see the car decelerate at the stop sign. You can see how that's correlated right there. We'll come to a, oh, was that not a complete stop? That graph did not touch the axis. Fortunately, the police don't have APIs, so we can't report you to the police. And we'd never do anything like that because we're not terrible people. But yeah, you can see coming in for a stop, and it's cool. We can actually use speed profiles that look like this in the machine learning to determine where stop signs are without having to use any visual features at all to determine the stop sign. So yeah, I mean, you expect this here to be a turn. You can see it's a turn. That's the steering angle. So we have a lot of stuff already figured out on the Acura, but there's a few things that we don't have figured out. So there's these like XXX4 packet. So if you look at this packet, you'll notice that there are no signals labeled for it. This one always seems to have that value. Let's highlight it and create a signal. Let's plot it and see if it ever changes. Nope, it looks very boring. Maybe there's nothing interesting on XXX4. How about XXX1? It's pretty boring as well. So you can kind of see how interesting a packet's going to be by looking at how red it is over here in the Signal Explorer. Red means that it's changing. So if we look at these ones down here, these are actually packets from the radar. So they're not filled in on this DBC because this is the Acura DBC and not the radar DBC. But if I go here and I plot this signal, you'll see that it's going to correspond to how close I am to the car in front of me. So let me just zoom in here. And you'll see, if you can see in the video, you can see that car off in the distance there. You can see that we're getting closer to it. I'm sure there's even much better examples of that. Yeah, so that's the first radar. The first radar thing usually ends up being the lead. And this route is available to everybody, so you guys can actually play along with me at home. So let's see, are we coming up on a car here? Let's move this over, and let's see if that works on the demo route. No, I'm seeing the same sync issues on the demo route that I was seeing with the other route. Guess we'll just have to wait till it's fixed. So there's so much CAN data on your car that it's hard to load it into the memory of the web browser all at once. So that's why we have this slider here, which lets you select the portion of your route that you're currently working with. It seems to only work right now on the first portion of the route, but I'm sure that'll be fixed up soon. Let's see. I get email. Should we have public email hour where I read emails? Are they interesting? They're probably not interesting. I usually get emails for people who want to, and I quote, like, collaborate on ideas. And I'm like, okay, so what's the idea? I tell them to be concrete. And I'm not sure if they know what concrete means, because I very rarely get like a concrete proposal. Like, I want this, or we have this, or let's make these two systems work together. It's more like, let's meet for coffee and chat. And, you know, I would drink way too much coffee if I took everybody up on those offers. And that wouldn't work. I mean, any sort of, and like VCs complain about this all the time too. Like, come to me with like a real pitch. Let's check out the pandas. Look at the panda. Huh. Okay, someone sent me an email with the subject batteries. You think it's interesting? Do I know anything about batteries? Let me read the email. We'll see if it's interesting while we wait for Andy to fix that bug. We can also check out how many pandas we've sold. How many pandas do you guys think we've sold? We have sold 350 pandas. It's pretty exciting. It's a few more than we expected to sell. 420. 420 would be nice. I mean, let's keep it rolling. So if we do manage to hit 5,000 over the next month, we're going to give all the early people the option of a 3D printed case or an injection molded case. Then people after that will all get injection molded cases. I think the 3D printed case looks pretty nice, but the injection molded case might look a little bit more professional. But yeah, you know, our main goal for getting pandas out there is to have people start reverse engineering all the cars in the world. Let's look at what sensors are on these cars. Let's look at how to control these cars. We thought about offering the Panda Ultra Edition, which is a black panda, and a panda in a black case, and that would be $188. Does it get you anything better? No, it doesn't, but it would be $188. It would be a panda in a black case. If anyone wants to buy one of those, email me. I'll sell it to you personally. When will drive sharing be available in Cabana? Yeah, we should work on drive sharing. So right now there's share features built into Schiffer, but I think they're limited to like GIFs and videos and small pictures. Someday. For now, you just have to let someone log into your account. But I mean, you can also do it with APIs. You can also do it with the Schiffer API. If somebody writes an app, they can grant API access using the Schiffer API, and that's all on our GitHub. What's the difference to Clavcar? I don't know what a Clavcar is. I'm looking on Twitter here. This is somebody. I should show you guys the Twitter when I'm using the Twitter. I think I can just do that. Yeah, there we go. What is the difference to Clavcar? Let's see what a Clavcar is. I should close my email too. That has secrets. And that doesn't have secrets. That's Google News. And that's my Slack with Andy about fixing your bugs. Clavcar. Well, that's expensive. 99 euros? See, so my problem with all these other dongles is that they don't tell you what... It's an Elm. Like the Elms do not let you read all of the data off of the CAN bus. They also don't tell you what ports... Oh, wow. Oh, wow. We just sold 5 more pandas. They don't tell you what actual connections there are on the OBD port. OBD. I always say ODB. It sounds better, but it's not. It's OBD. So we actually show you exactly what's exposed on our dongle right here. So we show that we have the 3 CAN buses, 2 LAN or K-line buses, and then 1 GM LAN. And that's like what it, the actual electrical hardware interface is. This pin is another ground. They're tied together on production pandas. This pin is not really used. It's used on some cars as like a special clear mode, but our panda doesn't connect anything to that. And this interface we call the JSHID interface. No modern cars really have it, so we just omitted it. It was extra worthless hardware. This is what really lets you get access to so every one of these CAN buses plus the GM LAN is on like the Chevy Volt and the Chevy Bolt, for example. So we want to make sure that you can get access to really all of the stuff about your car. Like CAN 3 on on the bolt is just a battery can. It talks about the status of each battery in the Prius, in the Volt. The Prius only has, I think it might have 2 cans. I don't know. But when we wired in the Prius, we actually wired the Panda into, I love Twitter. We wired the Panda into the same place that the stock camera system connects to. So if you watch that video. So I'll go back to my driving explorer here, and maybe things will start working. These are my drives of the Prius. Let's go to this one here. What's up from India? 357 pandas. 357. So many pandas. Oh, I remember what I did. I hid that window. Let's go back here. Don't open too many cabanas. It is a pretty intensive web app. Which vehicles are we most interested in next? The more people have the vehicle, the more interested we are in it. Newer vehicles have more sensors. But yeah, so let's X out of this one here, and let's go back to this Prius route here. Yeah, it does seem to be a problem only with this when I select things that are not the first. Oh, Andy's typing. Let's see what he has to say. Can't repro with the Prius route. I reproed with the demo route. Yeah. Maybe I wait. It doesn't seem to always do it. So maybe I have to wait for the first part to finish loading. Let's try that. So let's just refresh here. We'll wait for the first part to fully load in. This might be a problem with just zeroing the time. You can also check out where our Schiffer users are on this map here. So we have a lot of our Schiffer users in America, but look, we got someone down there in the Dominican Republic, and this is just Schiffer users in the last 24 hours. Scattered all over Europe. Over here, Southeast Asia. Indonesia, look over there. Cool. So let me scroll this now and see if it doesn't happen. Oh yeah, The lines are gone, but the jumpies aren't. You know, reverse engineering is a slow process. Still happening even after I wait. See, yeah, when I click here, it shouldn't like jump there like that. Maybe this is, it's not even synced up right. So if you see like when I click here, that's actually at the peak speed of the car. It just looks like the line is in the wrong place. Yeah, I think we can make this work for reverse engineering anyway. But we really want these tools to be a wonderful experience to use. It's a program that I used for a lot of binary reverse engineering called IDA, and it really is, it's a wonderful program to use, and you can just spend hours exploring all the stuff that's in a binary. So yeah, see, when I click here, it does that. When I click here. So yeah, wherever I click is where it's actually going. So we can make that work. that looks like where I changed lanes. And we can confirm that by turning on the steering angle plot. No, this is messed up. Oh, snap. $365 pandas. I do promise that these bugs will be fixed long, long before you get your panda. They'll even be fixed tonight because I want to start digging in and reverse engineering the Prius. I bought some cool stuff for the Prius. I bought this thing here. It is a USB monitor. So we're not going to put the big touch panel in the Prius. We're just going to put this guy in there. I also have a gaming PC coming in the mail today. Any luck?
No, let me watch you.
Yeah, all right. I'll show you what I'm doing. Maybe I'm clicking wrong. Let me put this monitor away. It comes with like a little carrying case too. It's cute. A little Asus thing. So I load up the Prius route, just refresh. So I can even wait. It still happens. So now that I'm loaded, I drag this over to here. I mean, a lot of times bugs are caused by people clicking wrong. Oh, yeah, 368 pandas. If you have a panda, can others go through the data? So no, if you have a panda, that data, we don't share your data with anybody. We could, people are asking a lot for that feature. They want to be able to share their routes.
Yeah, absolutely.
I think, yeah, we can try our best to make it happen. Okay, cool. So now it's just being slow. No, sometimes people click wrong, you know? I mean, sometimes it's broken, but sometimes people click wrong.
Let me point you to my computer.
All right, cool. Why is this slow? Community's fast. Cabana's just being slow. Oh, come on, Chrome. And he disappears when the bug happens. He's not here. Where'd he go? Save your DBC progress. I did. I already saved it and committed it to GitHub. So if you see, Cabana integrates with the OpenDBC project. Ooh, 370 pandas. Cabana integrates with the OpenDBC project, so I can load my DBCs here, and I can fork it to my own GitHub. So then if I want to save my progress, I can just go to Save DBC, and notice how it's forked to GeoHot OpenDBC. I can just click Commit to GitHub, and now it's shared on my GitHub. Okay. So Andy sent me a link to an internal build of Cabana. Oh, that's so fast. We'll make the real one faster. We'll stand up a caching server in front of the web page. So let me just log into this. Can I log into this with GitHub? Is that going to work?
No.
No?
No, it won't redirect.
Oh, because it won't redirect me to the right URL. Okay. So no DBC. But let's see if the bug still happens.
Oh, I mean, you can save it to a text file and load it from the text
I could
file.
save it to a text file. So you don't have to save your DBCs to OpenDBC. You can save them to text files. So I scroll to here. I don't even remember which one's speed now. You know where that would be? I just go on my GitHub here. Go to my personal GitHub, GitHub GeoHot OpenDBC. Then we can look in these DBC files. So DBC is kind of the industry standard file for car specifications that show you where the sensors are in your car. So these are the wheel sensors for my car. So you can see they're on packet 170, which I think is AA in hex.
Yeah, go ahead and
So let's go there and
paste in the raw DBC file.
I could paste in the DBC file too. Oh, it's not doing it now.
Yeah, I think I changed one line and.
Oh, you made a
I
change.
made a change.
Oh, you fixed the bug. All right. Well, the
Also fixed the lag that you were experiencing.
oh, this is exciting. And yeah, I mean, I think we'll leave it up for today, but I think we'll make this go away on the production ones.
Yeah.
Okay, cool. The bug is fixed. Thank you. All right, it's fixed. So yeah, we'll get that out. That's what's great about it being a web app. Yeah, we're on the Periscope. You wanna say hi to the Periscope?
Yeah, of course I want to say hi to the
Periscope.
This is coming to us?
Yeah, it's coming to us.
Hi
Yeah.
Periscope. Hope you guys are doing well and excited about the pandas. We're stoked on them.
Can they hear you? I don't know.
Hey, well, at least
Hey.
we got some people.
Yeah, Cabana is a web app. Yeah.
Tell them I lost money on a bet because I didn't believe in pandas.
Oh, that's true. That we had an internal betting pool for how many pandas we were going to sell, and if you bet on a lot of pandas, you won. Back now that we have bug-free OpenDBC. Not bug-free. There'll always be bugs. Bugs are an ongoing, forever struggle. So yeah, you just paste your DBC in here. So just go to raw, select all, copy, go here, paste, continue. Editing from paste. Oh, I see. Very high quality. Okay, cool. So now we have those signals we were working with before. And look, the lines are gone. And now when I click on the graph, notice how it actually goes to the correct place. So let's try to find where the braking is happening. So the car had the adaptive cruise control on, I believe at this point. You guys probably watched this video. How does a T-Mobile sync up differ from a T-Mobile sync up drive device? Do you think T-Mobile would ever make an interface that looks like this? I'm sure the T-Mobile drive device tells you how many miles you drove. Maybe. Someone show me a screenshot of that. So how does it differ? It gives you a whole lot more access to your car than any other reasonably priced dongle that had come before. In the past, if you wanted this kind of access, you were buying things from companies like Cavassar for $2,000. This competes with really the dongles that the manufacturers use, not the consumer grade ones. Okay, cool. So let's assume that this braking event here, so you can see it's a braking event because we lose a lot of speed quickly. Let's assume that this braking event here was caused by the ACC being triggered, right? So I have down here on new message one of these is, here we go. So see that this one here, track 0, is the, so these, you can see that some of these are zeros and some of these are ones. Zeros are on the first CAN bus and ones are on the second CAN bus. So I can go down here to this track 0, 1, and I can plot the longitudinal distance to the car in front of me. And this makes a lot of sense. You'll see that as I approach the car, well, I think actually the target changes there. So I think here, this is a packet from the radar in the Prius. So you can see that here, it's tracking this car over on the left. And then once that car leaves like the cone of influence, it switches over to this car, and you can see that kind of parabolic braking. This, by the way, is not how you want to really do it. This was kind of an uncomfortable braking event. I talked about this during the last live stream, but if you go to limo driver school, they tell you be hard on the brakes at first and then soften up as time goes on. Okay, so we have our wheel speed. We have our longitudinal distance. Let's take a look here at the brake packet. So to confirm that this actually is the brake pedal, I would expect, oh, it's not really the brake pedal because I didn't press the brake pedal. This was done automatically by the cruise control, so I think we should rename this to something that makes more sense. Maybe this one we'll call brake regen. You know, when you're reverse engineering, you just take a lot of guesses at names, and then you make it better and better over time. And this is going to be an ongoing project, and we'll call this one brake amount. Cool. And you can see this is all reactive. That version is deployed live now. Cool. The bug is already fixed for everybody. That was quick. Let's say thank you, Andy, on Slack. Or just say thanks, because it'd be stupid if I said thank you, Andy, on the Slack channel that's a DM to him. Yeah. Let's check the Twitter. I love Twitter. So back to finding the brake packet. So it's possible that one of these things was actually the trigger for the brake, though doubtful. One way we could test this is we could find another place in the route that I know I braked without using the adaptive cruise control. But for now, let's just unplot these. And I know that it's not going to be on the radar can, so I can use this filter here. And I can just say 0 colon is the filter. So it has to be one of these packets. Let's see if we can find one that changes right here. That one's kind of tempting, this new message 1 over here, and this signal here. Let's try plotting that, seeing what we get. Okay, well there's a lot of bouncing around 0. That's probably because it's actually a, is it signed? Maybe it's signed. Oh no, 0 just has a special meaning. Interesting. I wonder what that signal is. Does anyone have any ideas? Don't think it's the signal that actually triggers the brake, though. And I might have also kind of lined it up wrong. So let me try going there. And then say that it's signed, maybe? Yeah, okay, so that looks a whole lot more sensible. Notice how this graph really improved a lot. What this looks more like to me is probably something like an accelerometer, right? So this is and then when you're talking in a car frame of a car, the car travels forward in the X direction, and then Y is to the left. So I'm going to call this Accel X. Sorry, I missed that question. I haven't been good at keeping up with the periscope because the thing's a little bit behind where my eyes are looking when I'm on the screen. But yeah, so that just looks like an accelerometer. You know what? This one's probably Accel Y too. Accel Y, and we know that it's a signed value. So we can actually confirm if that's correct. So that's just a lot of noise. Now look at how small the numbers are. But we can confirm if that's correct by plotting it with the steering angle and finding a place in the segment where we actually steer the car. So that's Accel X, so that's braking of the car. But do we have a place where we steer? Here is where we steer. Do we steer a lot? Yeah, we do steer a lot. Okay. Maybe that's not Accel Y. Maybe that's Accel Z. It would make sense if there was another thing in there, but yeah, it could just be like acceleration in the Z direction, but that's a whole lot harder to test. So let's... Does shift record the phone accelerometer? It does. We should make it so you can graph that as well. That would be a good idea. We can then just correspond them, very simply. Accelerometer. Did I spell that right? I just Google things to see if I spelled it right. Cool, I spelled it right. Okay, but that's not what we're looking for. We are looking for the brakes. So let's just remove that signal there. We can unplot all of this. And let's go back to our good braking event. So this is our good braking event here. All right. So the radar is gone. Let's even go a little bit before the braking event. Let's see if we can figure out what changes. So we can look over here. Figure out what changes in order to trigger that. These packets look like they become active. That might just be the speed over here. No, it's not. It's not. All right, let's plot that, and you can tell that it's a signed value. So let's make it signed. Okay, that looks like something. Maybe this is the signal that controls the brakes. A good kind of way that I found to do this was, let's look at what else is in this same packet. Maybe we can guess. So another thing that we're going to have soon as well is live Kibana mode. So you're not going to need to upload your route to Schiffer, wait, and then process it in the past. You'll be able to do this all locally in real time. We're going to write some JavaScript code using WebUSB, which will just let you plug your Panda into your computer, go to kibana.com.ai, and then run it right there. Kind of like if you guys have used like MyEtherWallet. It's a JavaScript-based Ethereum wallet, but it can talk to your physical like cryptocurrency ledger. So it's the same kind of thing. Okay, so these signals might be something to do with the brakes. They're kind of interesting. I don't know. Well, okay. So the thing that we're going to have to check and compare it to is other places where the brakes are used. We want to find the one where it was autonomous on the brakes, and I don't think it's this, because this just looks like it correlates with, that looks like it correlates with the acceleration there, right? Like, so again, I don't really know what this signal is just offhand, but it's not what we're looking for, I can tell you that. Packets are tempting because they're quiet and then they come alive. They come alive right when that stuff happens, when the braking happens. Yes, Panda can read and write to the CAN bus, but when it's used with Schiffer, it's only used in read-only mode. Schiffer doesn't write to your CAN bus, but if you're using it in with like Linux Socket CAN or using it with something like OpenPilot, yeah, that's going to write to your CAN bus. There's a certain amount of caution to exercise with your writing, but it's not like you're going to mess something up probably the first time you do it. I do urge you to be careful, but at least when it's in read-only mode, you know that you cannot mess anything up. Is a 2011 Acura TSX compatible with Panda to take control of the gas steering and brakes? I don't know. I don't have that car. But if you watch what we do for the Prius, you can use the same procedure to determine if you can. If your car has adaptive cruise control and lane keep assist, like if you've seen the car hit the brakes or move the steering wheel, then there's a good bet that you'll be able to do it with Panda. If you've never seen the car move the steering wheel by itself, then you probably can't. All right, so let's focus on what we're doing. Oh, the Twitter notifications are so tempting. I love Twitter. So you see what I'm looking for here? I'm looking for a signal that's going to light up right when that braking event starts. So now there are worse possibilities. It is remotely possible. So these signals, you notice they have a lot less frequency than these signals. This is the count that happened in the 3-minute chunk that I'm currently looking at. So it's probably one of these more frequent signals. The brakes usually update pretty fast. Yeah, so the Common Neo, the board that's in the Common Neo is kind of like a Rev 1 of the Panda. Finding gas brake events is actually really easy. Finding the speed on a car is just usually trivial. You can just spot it because it's correlated with the video. But yeah, we should be plotting. We can get GPS speed, we can get accelerometer, and we can put all that data in the same format that you see here, and you'll be able to graph it. Coming soon to Kibana. Yeah, so Neo, actually, if you have a Neo right now, you can go on the Driving Explorer and you can use Kibana and you can do what I'm doing right here on your own drives. Panda is kind of just like the V2 of that hardware. If you put your car into a lower gear, the brake does push in automatically. Are you talking about like engine braking or actual like braking? So even if the car can't move the steering wheel or brakes, there's a possibility you'll be able to control it, but it gets tricky and fancy at that point. You might need to like change the firmware that's running on your car. it is doable, but be careful. All right. So this is the brake. It's kind of nice that the computerized brake shows up on the same graph as the human brake. On the Honda, this isn't the case. And then it just does a brake hold for you. That's a pretty smooth brake hold. Let's confirm that that's actually the brake all the time, even when I'm using it. Yeah, the ACC was not driving there. I was driving there. So that is a human brake event, and it's on the same axis, and then a brake hold. See that? You see that? See that linear? See that linear up right there? That feels super uncomfortable. You want to brake hard in the beginning, which it did, but then it looked like whatever its controller wasn't well calibrated and had this linear up. Although to be fair, that's after the car looks stopped, so maybe it's this up, because I remember the brake event feeling really uncomfortable. Oh. Okay. So I'm not actually on the remote one. I'm on Andy's local one. Andy, you erased my DVC. Yeah, you refreshed it.
Oh shit. Well, you can switch over back to.
Yeah, I'll switch out to the real one. No worries. I didn't have anything really figured out anyway. That was the leaderboard. That's not what I want with the Driving Explorer. So let's go in here to the route we were looking at, and let's see if that bug fix actually did go live. Erase, refresh. Well, so that doesn't actually happen on the real one. That's just because it's in React debugging mode. Oh man, it feels slower on the server. Big proxy. I'm going to put a big proxy. Yes, yeah, of course you can talk to it with iPhone. The App Store Schiffer Panda iOS support went out this morning, or maybe yesterday. We tried to get it expedited through Apple, but Apple didn't expedite it for us. But yeah, that will go out soon. Andy, the bug's still there. Did I not refresh well? I spammed refresh a lot.
Yeah, we should make it refresh cache when we deploy.
That's a good idea. Say, oh yeah, no, it's coming to iOS soon. Didn't tell you guys that? Alright, it's fixed. Yeah, I just spammed refresh. Oh no, it's still happening. Is it not? How do I force for control?
Yeah, Chrome seems to be really aggressive with.
Chrome is very aggressive with the caching.
Developer, and then go to network, and disable cache check mark.
There we go. Well, does it reload the cache? Does this disable writing to the cache or only reading from the cache? I miss caches. They make things fast.
Given the lag that you're seeing,
It's broken still, yeah.
yeah, okay. Your cache is definitely still reading from cache.
Why are you so sure about that? I disabled cache.
Because I've disabled cache before and still had to read from cache. I also saw your network requests, and there were too many fired at once for that deploy to actually be the one you're running.
Okay.
Go head to your Chrome settings.
Inspect. Right click on refresh. Oh, hard reload. Oh, look at the people coming through. Is that gonna do it though? I still feel like it's the same. No, it's not. Are you sure you deployed? Can we put a little version on Cabana? No, I've seen the bug. Let's check Twitter while we wait. I love Twitter. Make sure we actually. This is out on Twitter, right? How does it look? You bought a Panda. Do I think it'll work on Mazdas? Maybe. Reverse engineering requires a lot of patience. We will stick a version on Cabana, so you'll be able to know when which version you are. Oh, we're 10 to 20 employees. That's true. Should we update our Crunchbase? I don't know how to do that. Can we do that? Do you guys do that? I don't know how it works. All right, we're gonna get to 400 pandas probably on this stream, and then we'll do the panda telethon thing where we all chant till we get to 404. You guys can buy a panda and watch a number go up on the live stream. Show panda counter. So we are at 377 right now. Maybe I'll just leave the live stream running, point it at the panda counter, so you guys can buy pandas and watch it go up. Go buy a panda, watch it go up. Can we also add a panda firmware version on Schiffer? Yeah, we're going to get better about the Schiffer's panda firmware management. I think, don't make me buy 30 pandas. Oh, by the way, if anyone is watching who's interested, we have some bulk pricing for pandas too, if you want to be a panda reseller. Yeah, we did have someone come in and buy 10 pandas last night. Will the price increase? Yeah, maybe. I don't know. Let's see. No, I think it'll be 88 for a while. It might be 88 for the pre-orders, and then 99 when we put it on Amazon. Coupon code pandas. Yeah, I think maybe we'll send out. Maybe we could send coupon codes to people who have a lot of common points. I think that's a good idea. Yeah, already 30K in sales. We're doing quite well. I'm happy with how many we sold. So our hope was to sell 1,000 over the month, but at this rate, even with this is doubling my projections. So I think we'll end up selling 2,000, and there's some chance we'll get to 5,000. We're going to be doing some live streams. We're going to be showing off more and more panda features as they come in. What's the margin on one panda? Less high than you might think, especially at this scale. We are making some amount of money. But it's more about getting really high quality car interface hardware out there, because everything we'll do in the future depends on it. This is standard VC model kind of stuff. But yeah, okay. Are we fixed, or can I use the other one and not have it refresh on me? I don't know. Andy's gone. Right click. Oh, empty cache and hard reload. Wow, that sounds even better.
Deployed version works on my machine, George. You know those are your favorite 4 words.
Deployed version works on your machine.
No, even if you hard reload it,
No. So I found a new button that might have actually fixed it. I found the right click and empty cache and hard reload button. Yeah, it's fixed. It's fixed now. It's fixed now.
JavaScript is a separate file.
Yeah, wow.
The beats really fantastic.
Chrome loves caching. Typical developer. No, Andy's great, man. We wouldn't have these great tools. Oh, if you guys can't repro it, I don't know, it's working now. It's better now, so we know about the empty cache and refresh button, which is pretty cool. All right, 377. Are we going to get to 400? Can we get to 400 pandas? Works for me, won't fix. Well, it's got to work for me. That's how things work around here. All right. So let's go back to where we were. Oh, we labeled that accelerometer, but it's gone. We'll never see that again. Now I remember what it was. So we can add in those signals real fast again. So if you remember, they were sine signals. We're hiring a designer too. You should be able to not have to click like edit and save. You should be able to Just double click on these things. So we're going to call this one Excel Z. I'm going to call, oh, I can't even press enter to save. All right, we're gonna make that work. It is going to get much better, but actually, if you use the actual tools that cost a lot of money to do this, oh, they're way worse. And Kibana, of course, is free for people who have pandas or Neos. So you don't even have to give us any money to use Kibana. You could just build Neo. You just camera to landscape. I tried that and it didn't work well. It was disappointing. The results were disappointing because Kibana, probably not. It's probably not. Maybe we'll think about it. Look better on your screens when I rotate. Please do. It is a React app. We'll think about it. We don't want dongle makers taking our great software and putting it in crappy dongles. All right, landscape. All right, you guys really want that landscape. All right, let's try it. All right, I'm going to stand this up. Maybe this will work. Nope, that did not work. Oh, you know what? I think what'll work is if we spin this around. So I'm just using a mount, like one of the Schiffer mounts from my phone. You could actually read the words. Okay. We're going to make this work. All right, so first we go like this, and then... Did I find that computer? You don't like my keyboard? Hey, that's an expensive keyboard, man. It costs more than a Panda. All right, landscape is upside down and only looking at the keyboard. Is that better, guys? Yeah, okay, let's try. Okay, this isn't working. You know, this is why I'll never be a YouTube celebrity. Because I'm not good at pointing cameras at things. I could make it on YouTube. If only oh, okay. Oh, you know what we have? Oh, I know what we have. Oh, this is a good mount. This is an iAudi2, which you can buy from our Schiffer page, and we get referral money, so that's a good deal. Cool. I should get a head mount, yeah. All right, I'm killing you. I know. All right. Is that better? I don't know how these hearts work. Does that mean you guys are happy with what I'm doing? iAudi2 is what I have in my STI. Yeah, it's pretty good. Maybe we can even edit this to put the Panda number down here. So we can put that Panda sales right. Save. All right, 377 pandas, and now I'm feeling the love. All right, it's better. All right, cool. I'm glad you guys like it. All right. So let's go back to finding signals. The bugs are fixed. Everything takes time, you know. That's something you learn starting a company. You think you're gonna sell self-driving cars in a year? I don't know. Some part of my brain maybe thought that, but the truth is everything takes a long time. Shipping is free. Shipping is free to anywhere in the world. Mostly because I didn't want to have to deal with charging for shipping. So, you know, if you're in the U.S., you are amortizing the shipping costs for those in India and Switzerland and stuff. But, you know, hey, again, it's really just about getting the hardware out there, and about these. I always say, like people were asking me about Baidu and how Baidu stole the Android of self-driving cars line. Like, yeah, I mean that's what, you know, they but they're not our competition. The battle is between open and closed. So yeah, you know, the more of these we get out there, the more open, hopefully, cars will become. Okay. So let's rename this message to accelerometer We'll also add auto population of the size of these messages, because I actually think this might be a shorter message. And we know how big the messages are on the bus. Yeah, most of this is just trial and error and just kind of guessing and drawing plots and being like, does that look right? Like, I don't know. I don't know what this is. So let's just draw a graph of it and let's see. It's very noisy. Well, that's probably because these aren't all the same signal. Or maybe it just is that noisy. I don't know. There's other things you can tweak too, like the endianness. So actually, we have it, if you drag it like this, it's little endian, and if you drag it the other way, it's big endian. You can also change that endianness right here, but let's remove those signals. Those don't look like anything good. So yeah, I mean, to be honest, this thing's just a lot of fun to play with. You can sit here and just look through all the signals in your car and take good guesses at what they might be. But we are on a mission to find how the car hits the brakes. So there is some chance that it actually isn't on here. And it's hidden in some other bus of the car. Because we didn't log all the buses in the car. Some of them you have to get to with, by sending the right sort of commands to bypass gateways. Now, one of the interesting things that Panda is going to offer is being able to be used with these I don't think this is refreshing. Being able to be used with these Windows tools that you can get from the manufacturers. You can go to HondaTechInfo.com, you can go to Toyota Tech Info, and you can find all of these manufacturer tools which let you access your car. They're mostly for mechanics, but you'll be able to actually use those with Pandas and not have to buy the $1,500 Bosch interface, which is pretty cool. All right, let's put that filter back on. 379. Come on, let's get the 400, guys. We can do it. 400 Pandas. At some point, let's chat as a subject of an email. I predict 1,200 by Monday. That would be nice. I got distracted by email. What was your question? If you say it again, I'll answer it. What is this? It's kind of interesting. Look, there's all these like signals on the car. What are they? Yeah, the DBCs that you create in Kibana can definitely be used by OpenPilot. Actually, if we go to the OpenPilot repo, you'll find that it's actually using this OpenDBC project here. And OpenDBC is the same project that Kibana interfaces with when you go to load DBC and save DBC. So these can directly be used in OpenPilot if you find the right messages. 381, come on, let's keep it going. 400 Pandas. What do they do on telephones? Is the Panda eventually going to replace the Neo? Well, the Panda can't replace the Neo. The Neo is hardware that runs our self-driving software, but there is a board inside of the Neo. And yeah, I mean, you can already replace that board with a Panda. We have this board called the Giant Panda. It's in the Neo repository. Are automakers going to encrypt the CAN bus? I get this question all the time, okay? Look, Apple tried for years to stop jailbreaking. They eventually succeeded, but it took them almost 10 years. And that's Apple. Do you really think there's any way the automakers can keep me out? By the way, you have a right to do this stuff too. There's a bunch of bills in Congress like right to repair, DMCA on cars. I mean, you know, if you're adding functionality or you're repairing functionality on your car, it's well within your rights. We will be at 600 by tomorrow morning. Yeah, I could see that. I could see that. Yeah, it would take them 10 years if it's even sort of possible. I mean, a CAN message is only 8 bytes. There's this thing called CAN FD, which can do more bytes, but that's a long way away too. All right. Pressing on the brakes. Where are we pressing on the brakes? This one looks like it's changing, but it's changing slowly. This is something, but it doesn't look like the brakes. That signal's kind of interesting. Let's plot it. Oh, this could be the signal. Watch. So what this could be is kind of a... No. This looks more like maybe what's happening with the suspension of the car, maybe the tilt angle of the car, right? Because you think about how a car is going to come tilt. Audio will help you log things. Yeah, I mean, yeah, we'll probably add that to Neo and Schiffer at some point. It'll be very much opt-in. Audio and front cameras are very sensitive stuff. We're never going to log those by default. But yeah, no, I mean, it would be a helpful tool to reverse engineer if you could record the audio as well. 384, guys. All right, so I don't know what this is either, but there's like fascinating signals in this car. Probably not that one. So maybe we'll just name this one Tilt Shit, maybe? Cabana open source. We'll see. We'll think about it. Maybe the land. Oh, you mean like the derivative? I shouldn't call this tilt shit, maybe. I should call it something better than that. Those things just seem all over the place, too. I mean, they might be part of it. Maybe this is just a super big signal. Does this work with 32-bit signals? Or maybe it doesn't work with 32-bit signals. Oh, okay. All right, we'll add that to the list of bugs. We shouldn't call it tilt shit, maybe. We'll call it suspension. That is not how you spell suspension. But that's why we have Google. Thanks, Google. Pen. Oh, it is how you spell suspension. All right, cool. Probably not what we're looking for. So those ones are active the whole time. Okay, look at this packet. This packet starts to do stuff once the braking starts. So you see it's nothing. Oh, okay. All right, I think we're onto something. Notice how it's nothing? It glitches a little there, and then there we go. Now it starts braking. Okay, and that looks like it's going down with the... Yeah. Is this the one we found before? And let's make that. That's clearly signed. So is that the brake actuation command? So this makes sense. Braking, force on the brake is fairly linear with, no, maybe not. Let's check out this one. Now, imagine doing all of this stuff without Cabana. it was super tedious and annoying. Like every one of those things that I'm doing now with a couple mouse clicks would take, you'd have to plot that in Python. You'd have to write Python code in a notebook. Hello, I'm watching you. You'd have to plot that in a notebook, and it would take a lot of time. All right, so this definitely has to do with the brakes. I think this last thing here is some sort of checksum, but I don't really know how it works. I'll just call it checksum. I know how the Honda checksums work. So one thing I actually like about this car less than the Honda is the Honda doesn't just have a checksum, it has a counter. And counters are really cool to make sure that your interface is not replaying stale data. This car doesn't look like it has that. So you can actually go in here if you want to expand one message, you can expand it and you can see what the actual values of these are at any time. I can throw those on the plot real quick, close that up, hit play. Okay, so that definitely has to do with the brakes. So the way these messages work is they usually come from one of the modules of the car. So there's a chance this is brake command and this is brake actual. All right, so now let's zoom out and see if there's any way that's correct, because we should not see that wherever we... no, we see it here too. It's very clean though. Wait, again, this is where I was before. How does this go up when the car accelerates? Oh, I might be really dumb. You know what this... No, but how come it totally drops out there? This stuff almost looks like it could be like RPM or something. See, what makes this car extra tricky is the fact that it's a hybrid. I've never reverse engineered a hybrid before. So this has a gas motor and an electric motor doing different things. Let's see. All right, well, those are not what we're looking for. 387, let's get to 400, you guys. Yeah, the hybridness of this car makes it kind of tricky. I'll get better about this. Maybe I just need to read up more on hybrids. You know what? Let's do a little reading. So one of the ways that I've found to learn things about cars is you can go sign up on techinfo.toyota.com. Comma AI, a secret password. Check Slack. Yeah, maybe the best way to talk to me is on Slack, because I can actually look over at that monitor. Would this help you? Oh, I forgot about this. Wow. Somebody did a communicating with the Toyota Prius. Oh, this is exciting. Oh, you Slack bros, you guys are great. All right. We got somewhere to start. Let me just put this up here. Okay, so we have this PDF communicating with the Toyota Prius. Decoding the CAN protocol. Background. Oh, hybrid synergy drive. So hybrid car technologies, fancy. All right. Yeah, so they're wrong. This is actually only a 500 K bus. There's also the Charlie Miller paper. Maybe we can learn stuff from there. Location of CAN components. You see what I mean? They're not telling me. Okay. All right, here we got some numbers. So these numbers are supposed to correspond to these numbers here. It doesn't even look like we have the same signal. So I'm looking for like the gas pedal position one or the steering one. No, they've changed it. This Prius is too new. It's too new. So you see these IDs here, I'm searching for them in the data. And the ID, by the way, is that like number next to the 0. It's too new. It's too new. You know where I have a resource? Income AI bounties. Let's see this one. Here we go. Speedometer Toyota. Let's see if this one matches up. So they put pages, but they don't actually put the page numbers. So by the way, yeah, these graphics were taken from this Toyota TIS thing. Okay. So this is braking. Let's start with the easy ones. Like if the speed doesn't match up, then it's not going to be here. Speedometer Toyota is on 0B4. No, I don't have a 0B4. Oh, yes, I do. I do have a 0B4. Oh, this looks exciting. Okay. So they're claiming that they're claiming that it's going to, ooh, this is really exciting. I think this matches, right? So let me just move this over a little bit. What? No, that's not what I want. Okay, so if this is correct, we're going to put this, you can see. Let's put it over here. You have a question about Schiffer before using it. Tell me what your question is. Okay, so these look like they're all zeros. That's true. This is a counter, according to the Charlie Miller thing. So yeah, look, it's a counter. Now, it doesn't look like it iterates constantly. It looks like it iterates based on speed. Okay, it looks like they didn't maybe do the best job of reverse engineering themselves. But it is, I mean, it is a counter. Maybe it's, or maybe that's like the odometer itself, right? So let's not call it counter. Let's call it odometer. Or maybe the better word is even encoder. You know, just like it's like a shaft encoder. This one, I agree with them that it's the checksum. Oh, now we're finally breaking some stuff open. So yeah, just search for, it's actually on our bounties page if you want to get access to this resource as well while I do this. So yeah, it's an encoder and it depends on your speed. Like that's how it depends what like the slope of these lines are, right? So they're claiming that this is the speed. Let's see if that's true. And maybe they talk also about where the speed comes from. Yes, that's the speed. Look how well it matches up. Okay, we are getting somewhere. This is very exciting, you guys. This is the most exciting part of this Periscope yet. This will even be more exciting than when we sell 400 pandas. So what is this? Okay, so this is, man, you know, I bet you the guys who wrote this paper wish they had this tool. Speed, because they did it the painful old school way. All right, so do they talk about where, so this is the speedometer speed, so that usually comes from the transmission, and then the wheel speeds are a packet that goes to the braking system, but okay. So speedometer is kind of boring. Let's see if the braking packet matches up. So they're saying it's 283. Look at this, 283. Let's see if it's actually the same packet. It actually looks like it does nothing. This packet does nothing. Okay, so you know what they call that? They call that fake news. That packet is fake news. More comma points. Well, the raw data, no. The raw data is not available to the public. Yes, some still images may be available in comma coloring. That's definitely true. What's the guarantee that comma will be open? I mean, you never get a guarantee of anything in life. The incentive, well, you get a great dash cam, you earn comma points. You know, you're getting cloud storage for free. Like, to be honest, it's costing us money to store your data, and you're training OpenPilot. As a company, do you have a promise that the driving model will stay public? Well, we talk a lot about what our... I'm reading off the Slack, by the way. Probably shouldn't do this on the Periscope. Do you have a promise that the driving model will stay public? We've published pretty openly what our model is going to be, what our monetization and what our plans are as a company. Okay, so what's interesting is even though this packet is empty right now, this document is referring to it as the pre-collision system. So let me create this signal and we'll call it pre-collision, because even though it doesn't send anything, it might be different from the adaptive cruise control. We may be able to spoof this packet and hit the brakes of the car. So that is a good thing to know. Acceleration. Acceleration could be directly linked to a single CAN ID. So they're talking about this as 37. No, now they've lost us. We don't have a 37. No 37. Ah, 266. And this is supposed to be the steering packet. Oh, yes, okay. I think this is how we control steering. Steering control. Oh, okay, you know what we're going to do? There's actually a place in this video where we use the intelligent self-parking system all the way at the end. So let's scroll over to that. X that out. Oh, this is very exciting. Oh, look what's happening again. Look, it's glitching again. I guess I scrolled way too far. Charlie Miller's paper matches what we're seeing on our Prius. It's exciting. $392. So many pandas. Let's get to 400. All right. So let's plot this. What are they claiming these things are? Flag and angle. Major. So yeah, they have like a weird byte encoding of this stuff. In terms of nibble and minor angle. So actually what this should be is, we can actually remove this signal. They're saying this is the angle. So this is where the self-parking here happens. But it looks like that bug is rearing its head again with the multiple in the graph. 393. Let's keep it going. Let's keep it going. Okay. Let's scroll back to here. Hopefully the bug will go away and we can test it over here. All right, let's save this DBC to GitHub. And then I'm going to refresh this page. And we're going to look seriously into why this keeps happening. You don't actually have to save the DBC. If you refresh it, it shouldn't go away. It's saved in local storage in your web browser. Man, the signal's all over the place. I don't really think they have it right. It might have something to do with steering, but 7 more. and you could experience all the joys of reverse engineering your car like I'm doing right now. So what's that? So okay, that is when I turn the wheel. So it's certainly related to the steering angle, but I think that they went too far. I think maybe it's that. Or maybe not that. Or maybe it's just that one there. Oh, no, I'm dumb. I'm dumb. Look at what I'm doing, guys. So you see how this is A and AN? That's actually only 12 bits. I was looking at 24 bits. So that's in the wrong place. They're right, I'm wrong. Remove. Let's do the... Okay. This is our auto ND in this detector. Let's just go in there like that, go in there like that, go in there like that. Oh, this is fun. Oh, I love when things just work. Okay, so that is a flag. And that says whether the Intelligent Park Assist System is enabled, and this is an angle, according to them. No, that's too much. That's better. And then we want this to be a signed thing, because things like that are signed, because you can turn a steering wheel both ways. All right. Ooh, that's a clean signal. Take a look at that. So that's going to be a steering to the left, and then this is going to be a steering to the right, I assume. My mother just texted me. She said, "Great press, excited. I hope you sell 1 million." We can make a lot of pandas. If we actually sold 1 million, I would get on the next flight to China, and we would really have to ramp some things up. Yo, you see the panda numbers? We are at 394. We're right now on a live stream with the good folks at Periscope, reverse engineering the Prius and watching that number go up.
Incredible.
Right? So, Viv owes you $10. I already paid Eddie his $5.
You and your pessimistic probability chart.
Hey, my moderate probability chart where I was a market maker and it was hard for me to lose.
That's a lot.
I know, right? No. I mean, it's double what we predicted.
Yeah.
So we'll see how that continues out. Yeah.
The news articles are pretty good too.
Yeah, the articles have been good.
Pretty good.
Been fans. All right, cool. So let's see. Now let's plot this flag, right? So this flag never changes, but it should, according to this document, be set to 3 when iPass is enabled. Oh, now we're getting all the emails from the VCs. All the VCs who want to give us money after they read the articles. We tell the VCs no. That's a bug that we need to fix too. I mean, it's not a huge bug, but we should make the things. Oh, look at this! Oh, guys, will you look at this? Will you look at this thing here? You see that 3? That means we're in iPass mode. Charlie Miller, you did a great job with this reverse engineering. Thank you very much for helping us out in creating this DBC file. And watch, the car's about to park itself, and it's about to command to angle, and that is what's going to let us drive the Prius around the city. So I didn't find the brake packet, but I did, with some great help, find the steering control packet. And can I show Global Panda purchase map? Hey, what if I had it? No, these are low tier VCs. I mean, some of them are all right, but you don't want, you want people who are going to add value in your company. This is why I always talk about ICO stuff. Who's going to add more value to the crowd? I think it's really aligned with value creation, more so than the traditional VC model, which maybe makes a few people rich. We do crowd, make a lot of people rich. Oh, don't apply to Shark Tank. That's the lowest of the low. If an idea's on Shark Tank, I mean, there's taking money from the Crown Prince of Dubai, and then I think even below that there's Shark Tank. But yeah, so look at this, look at this. This is as the wheel turns, so that's the steering control packet. This thing is amazing. Although this, okay, so according to this documentation, although the servo packet has been reversed, the car still requires the current gear to be reverse. Oh, this is the current gear can ID. Okay, cool. Cool. Oh, man. These people are great. Okay, so that's what I called suspension, maybe. Shows you how much I know. Okay, it's car movement kind of stuff. Data. V1. What's V? Variable used to designate state of the car. State of the pedals. PD is car movement. GR is gear and counter. Okay, so I'm wrong. That's not a signal. 396. State of pedals. Let's plot that PD thing. Car moving. It's that here. It's an 8-bit signal and it's signed plot. I'm gonna plot this. Plot. Car movement. Okay, so this is car moving forward and this is braking or reverse. Oh, I guess that's braking. Okay. So they call this car movement. I'm going to stop calling it suspension. We're going to call it, it's usually like maybe the body packets of the car. I don't really know. Gear, not fear packet. Gear packet. So that's the car movement. And then these next things are the gear and counter. So this is the gear the car is in. And this is a counter. And this here is the checksum. I'm sure we'll figure out how to compute these checksums soon. We want to start sending these messages. But yeah, so this one here is the gear. Not fear. All right, keep doing that. All right. Let's plot the gear. All right, so you can see that, yeah. So they say 3 is drive and 1 is reverse. So we should actually, you can set that kind of stuff in DBC, and then 1 is park. So you can see that I'm in drive here. We don't need to plot maybe that. No, we need to plot that. Let's just plot car movement. All right, so you can see that I go into reverse here. I'm back in drive for a little bit here, and then my car's in park, right? So look at this. Licensed to car manufacturers. Licensed to car manufacturers is a scam. I mean, maybe someday. I don't want to think about it really as like a licensing deal. I want to think about it more like Sirius Satellite Radio. They include the hardware with their car and will provide the software. The software is free. I mean, it's software as a service. So you install the software, and then OpenPilot has a monthly subscription fee once it gets really good. So we can label this one here 2. This thing counts when moving. That doesn't even really seem like a useful signal. I'm not even going to label that one. Oh, this is exciting. Let's save our newly found information to my GitHub. So by the way, this is going live right now on my GitHub. If you go to GitHub GeoHot, I don't think I have too many embarrassing private repos. Maybe I do. But yeah, you'll see that this is going right now to Toyota Prius with the OpenDBC updates there. So you can see the pull requests that are automatically being created when I click pull to GitHub, and you can see that this is that gear packet that we just reverse engineered in the DBC file format. So it's pretty cool. Sweet. Let's see what else we have. Here's another speed packet. Okay, so this is the packet responsible for reporting speed to the system that does the steering lockout. I already have that one figured out. I just didn't call it speed. I guess they already posted it in their paper. So yeah, you see that the speed is not forward or negative. It's not positive or negative. It doesn't go negative in reverse because of how the wheel encoders work. They're not quadrature encoders. They're just normal encoders. 398, folks. 398. Okay, so then they talk about what packets they send. Oh, then there's also an LKA packet. Oh, exciting, exciting. All right, let's see if we can get that one. This is the steering LKA. And then let's rename the other one. Whoops, that's what I wanted to X. Not to be steering control, but we'll call this one steering intelligent park assist system. Cool. All right, so let's do this one quickly. See, this is actually a lane 5 packet. Our thing should tell us that, but this guy here is a counter. Major angle for the steering wheel. Carry over. I don't know why they describe it like this. Let's just talk about it like the way DVCs talk about it, but that's an angle. This is called LKA state. And this is a checksum. All right. Car movement, gear. All right, we're going to move away from this because that's the intelligent park assist stuff. Let's see if we can find where I actually use the lane keep assist system. Let's plot the angle right here. Oh, look right there. Look right there. It does something. All right, now, of course, it's signed. So we're going to have to go in here and change that to signed. Yeah, okay. All right. The bug is back. But either way, this is where the lane keep assist system triggers. Thank you, Charlie Miller. You've done a great job. And actually, let's really thank the authors of this paper because this is pretty awesome. So it's Charlie Miller and Chris Vlasic, really some of the early pioneers in car hacking. And they've published this nice information for us, and it is still relevant today and will be used to create our Prius DBC. So let's save our new changes to GitHub. And I think that's mostly what we're going to show today. So that's how you can start reverse engineering your car with Kibana. Data was recorded with a Panda. You can go right here to buy Pandas. I'm sure you guys have all seen this page because I'm sure all 61 of you have bought Pandas. But if you haven't, now's your chance to make that number go to 400. Let's sell 400 Pandas. So yeah, maybe the bug will go away. So I'm going to sit down with Andy after this live stream is over, and we're really going to work on hammering that out. Never want to see that happen again. You won a Panda. Congratulations. Pandas are pretty cool when you win them. Pandas are pretty cool when you buy them. Pandas are just pretty cool. Unlike me and the sunglasses, that's not cool. I've heard you loud and clear, YouTube. Okay, cool. So now let's zoom in on this, and now we're going to see the lane keep assist system trigger. We can go over to the steering packet, 399 Pandas. Let's keep it going. One more Panda. And we can actually plot the angle here too. Wow, it looks like this car has a lot of angle sensors. All right, so watch. Watch, I'm about to drift out of the lane, and now lane keep assist triggers to push me back, and we're going to switch up that lane keep assist system with OpenPilot, which does a much, much better job. And I love how simple these packets are. This is super nice. Thank you, Toyota, for making cars that are easy to hack. You guys are bros. You are bros. Is that what PewDiePie says? I'm a big PewDiePie fan. Not big enough to know what he says. I've only watched like 10 of his videos, but PewDiePie is the most famous YouTuber of all time. Oh, wow, they show you how to honk the horn. Oh, this is going to be great. Actually, even if someone, wow, this is super useful stuff. Yeah, Krabby OEM Lanky Persist. And that is 400 pandas, guys. That is 400 pandas. I'm so proud of the Panda team, everything we've done, and hopefully we can all come together as a community and start creating these DBC files for cars. So I'm going to do one last commit to GitHub right here. And I think that is going to be me signing off unless there are any last questions. Let me tilt this back. We can take a look at can Panda be used on Tesla? Yeah, it can. You're not going to get too much on the OBD port, but there's an instructable that shows you the right place to wire it in. And that good for the Dubai Crown Prince. I shouldn't say anything bad about the Dubai Crown Prince. I mean, he's the Crown Prince of Dubai. I'm just saying, like, there's who you want to take money from as a company, and like top tier VCs. And I think, like I said, I'm a big fan of ICOs. I think that's a great way forward. We're actually at 401 pandas. That's too many pandas. We're going to stop the video at 400. What happened? Now you just need to get a car that is supported. Yeah, I mean, the Panda stuff is entirely open as well. Does Tesla have similar tools internally? I bet they're nowhere near as good as this. To be honest, I bet they're nowhere near as good. Upcoming giveaway pandas, we have a bunch more Rev Bs to give away. But yeah, eventually they're going to be Rev Cs as well. So there are still Panda giveaways organized by our administrators on the forums. I will give away a couple pandas every week. What car works the best with OpenPilot? Right now, the 2016 Honda Civic. That was last year's flagship model, but we've announced that this year's flagship model is going to be the 2017 Toyota Prius. So if you want the car for the future, get that one. If you want, Honda Civic is a pretty good experience. It's not going to be quite as good as Tesla Autopilot. It helps a lot, but Tesla's deeply, Tesla made the car. But actually, a lot of that we can fix. We can fix with software. So pretty good experience in the Civic. Good experience in the Civic. Better than the ILX. But, this year's flagship, Toyota Prius. The Accord. I wrote half Accord support, and then I got bored. Somebody can finish it, especially now that I just really wanted to make sure that the Panda hardware can support the Accord, and I can tell you that it can, because I've seen everything get triggered. It's just a question of wiring it all up and making it nice. And if you do this, there's $2,000 for you. Can you order Comma AI? Oh, the swag items. No, I extended it. I was nice. I extended it from 100 to 200. Do I plan to celebrate? No, I plan to hack my Prius. I'm going to go, maybe I'll live stream again once we actually have the wheel turning. But yeah. Cool. Well, thanks for tuning in, guys. That was reverse engineering of the Prius. Bye-bye. Oh, I swiped down. Okay.